All right, as we look at 37 through 45, that's this F prime kind of thing. So if we look at what they're asking about, let's just run through this quickly. I want to talk about how I want to make sure you give your answers tomorrow. So this, I believe, isn't this the F prime graph on this one? So therefore, when they ask on 37, on which intervals is F increasing? Of course, thinking of the chart, F is increasing when F prime is positive, so that would be from -3 to 4. Now, we don't care about this part right here where it is 0. Even though our chart says that F is increasing when F prime is positive, what we really mean there is greater than or equal to 0, right? So it's okay that it hits 0 right there. Now, if the question would have been, where is F prime positive? We wouldn't have included the 3, right? Because it's not positive at 3. F prime is not positive at 3. It's 0 then. So that's a little bit of a difference. But when it's asking about increasing and decreasing, we can go ahead and include when it touches the 0 there in a flat spot kind of a situation, because it is still increasing when it's at a flat spot. Okay, so that's how I want you to give the answer, -3 to 4. Now, could you, I guess if you just want to be one of those people, or I just think of a few that might want to do that, just to be one of those people. But I mean, that's the same thing, right? But this is just a quick, easy way to do it. And if you write it, if you want to be one of those people and write it like that, and so while I'm grading your test, every time I look at one of yours, I've got to kind of transfigure whatever, and then I get angrier and angrier. And if that's the mood you want me to be in when I'm grading your test, I guess that's up to you. But anyway, you might want to do -3 to 4. Okay? All right. Number 38, where is F decreasing? Well, that'd be from -4 to -3, right, where F prime is negative. Again, this one's boxed in, so we would just assume the domain is from -4 to 4. If you get one where it's not that kind of situation, it's not a huge deal. I'll probably help remind you that when I pass out the quiz anyway. 39, where does F have stationary points? We want to write it as x equals -3 and 3, where F prime is 0. So write it kind of like that. All right? Where does F have local maximum? There are none. Local min, -3. Now, probably on the quiz there will be an added statement there to justify your answer. And so if you were supposed to justify why it's a local max, or in this case a local min, you'd want to say because F prime switches from negative to positive. That's what you want to say. You want to say because F prime switches from negative to positive is why that's a local minimum right there. Okay, what was the next question? Local, no. Is F concave up at 2? No. According to the chart, F is concave up when F prime is increasing. In this case, at 2, F prime is decreasing, so therefore not concave up. And it did say justify your answer, so that's what you would explain. Where does F have points of inflection? Right there and right there. Local max and local mins of F prime are inflection points on F. Now, if we go back to our chart, the reason for that, we remember, the reason for that on the chart was that inflection points happen when you switch columns here, switch concavity. So therefore, F prime has to switch from up to down or down to up. Okay, well that happens at a local max or min. So if we go back to here, F prime is up, then down. F prime is down, then up. That means F will be switching concavity. So that is an inflection point. Okay, number 44, write the tangent line equation. So those should be easy type problems. All we have to do is, let me go to one here, y equals blank, x minus blank plus blank, so they give us the point negative 3, 2, and what we need then is f prime of negative 3. So we go back to our f prime picture, and where am I at here? Right here, and f prime at negative 3 is 0, right? We just read right off of it. And so we've got 0, so our slope is 0. You can leave it like that, although 0 times that actually makes it pretty easy to simplify like that. Okay? So, they give you the point, they ask for the equation of the tangent line, they want that. All right, number 45 is pretty much the same thing as that. All right, let's go over to section 1.7 then. In section 1.7 is where we added the whole business with the f double prime. So over here on my graph, on my chart here, we'd be talking about this would be f, this would be f prime, and this would be f double prime. So the new thing yesterday was really kind of this section here, right? The red section right here is exactly the same as, this will get confusing, this red section, right? Those two red sections are exact duplicates of one another, right? F and f prime, and then the bottom right red section is f prime to f double prime. Those are exactly the same. But the real new stuff is this blue area, okay, this blue region. And this is the region that says when f double prime is positive, f is concave up. When f double prime is negative, f is concave down. And when f double prime is 0, you have a possible inflection point. It depends if f changes concavity. So it depends if f double prime switches from positive to negative or negative to positive. That's what determines an inflection point. So that is really how we kind of look at the chart, okay, as far as some of those different things that it's telling us. Okay, what questions do you want to talk about? For sure, we're going to do 21 and 22 on 1.7. What are some other ones? And I do want to talk about 43, okay? So does anybody have other ones they wanted to talk about? And then don't be afraid here, you got quiz tomorrow, this is your chance. 44, okay? Talk about that one. What's that? 33. Okay, let's start with those. And if somebody's got another one, be sure and let me know here. Okay, let's talk about 33. It says that you are supposed to draw a graph of f that has these features. F greater than 0, which really means, is another way of saying what? F positive. And then we want f prime greater than, no, f prime less than 0, which means f prime negative. And what's f prime negative mean? F, well, yeah, but I mean for f. What's it mean for f? Decreasing, right? So if f prime's negative, we know f is decreasing. And then we want f double prime positive, which means f what? Concave up, right? F double prime positive means f concave up. So we want an f graph that is positive, which means above the x-axis, is going down, but is concave up. Well, one option would be just the left half of a parabola. That would be positive, it would be decreasing, and it would be concave up. That would be one option. Yes? Where it just stops? I think so. But if you didn't, you're right. I mean, what if you had to have one keep going? Well, e to the negative x, which is actually number 44. Yeah, number 44, e to the negative x would be something like that. But yeah, I think you can just draw a piece of one. I think that's reasonable to do. Okay, 32 was very similar. The difference was it was supposed to be positive, increasing, and concave up. So that could be just the right half of a parabola, or it could have been e to the x, plain old e to the x. So that's what was going on there. So that, you know, be able to do that kind of thing as well. It's using information kind of from the chart to think about these graphs. All right. Let's talk about 22 and 23. 21. Well, I take it back. Let's go to 43 and 44 first of all. 43. Or excuse me, 44. Let's do that one first because that's probably the well, I don't want to say the easier one. It's the more boring one because the graph doesn't do much. Okay. Now again, you would have been allowed to use your calculator here. I'm probably not going to ask you to graph any on your calculator for the quiz. I'll probably just give you the graphs. We are going to use the calculators for the quiz, oh, by the way, so make sure you have it charged up and ready to go tomorrow. Short part of the quiz, you're going to use calculators, but I don't think I'm going to have you do this graphing part. Now, to be honest, very next quiz and going forward, you should be able to do this. Like e to the negative x is a pretty easy graph to draw. It's a negative on the inside, which means all it is horizontal flip, and it's of the regular e to the x graph. So all it is this graph right here. Okay, that's the e to the negative x graph. Okay, so we really need to use those things we learned about flip and those kind of things and what the basic graphs look like. We really need to be thinking about those. Okay, here it is. Now this is supposed to be f double prime. So we're supposed to ask these questions. Okay, A says where is f concave up? F is concave up when f double prime is positive. This graph is positive always. So this would be negative infinity to infinity. Okay? Where is f prime decreasing? According to the chart, f prime is decreasing when f double prime is negative. This is never negative. So therefore it's never. This is what I mean by boring. How many stationary points does f have? F has stationary points. Is it f? No, it's f prime. I was going to say. Stationary points of f prime is when f double prime is 0. This never is. Okay? Does f have inflection points? Well, that's when f double prime is, well, switches from positive to negative, right? Inflection points of f is when f switches concavity. Well, that's when f double prime switches positive to negative, which this never does. It's always positive. So no inflection points. Sketch a graph of f prime. Okay, so f prime, these y values are the slopes that we're going to draw. So these are positive and getting less positive. So our graph is going to go up and kind of level off, but never quite level off. So it's just going to be that kind of a thing. Okay? That's going to be f prime. So not a lot, you got a lot of twists and turns and peaks and valleys. It's a little more interesting. So let's talk about 43. 43, let's see, let's just go to the calculator. Here I've got 43 graphed here. Okay? So again, this would be one that down the road here, we'd want to be able to look at this and say, hey, that's a cubic. If you FOILed that all out, that would be an x cubed. So it's one of these kind of ones like this. It's a positive x cubed, so the tails start down here and go up here. Okay? And here's something else. You know it's going to hit the x-axis at these 2 points, at -1 and at 2. Now, here's another little trick about cubes. Whenever you get a double root like this, like a square, it bounces off. Now, you can figure that out by plotting some points, but you see at -1, this bounces off. Okay, so having them in their factored form is a real help in graphing. But again, right now, don't worry about that. So I give you this graph, and I tell you that that's f double prime. So as we go along, like I said, I think it's important that you do kind of know these things about these different polynomial functions, but it's not going to be life or death very often. Okay, but I keep reminding you of some of these things, and when they pop up, hopefully you can put them to use. Now, let's go through those questions. F's concave up whenever this graph is positive, which would be from 2 to the right, 2 to infinity. Okay, where is f prime decreasing is when f double prime is negative. So that's from -infinity to 2. And again, we don't care about this one here because the question was when's f prime decreasing. If the question would when's f double prime negative, we would have excluded that. Okay, how many stationary points does f prime have? That'd be when f double prime is 0. Has two of them, at -1 and at 2. Okay, how does F have inflection points? That's when F double prime switches from positive to negative or vice versa. How many? And it is at 2. Right there, F double prime switches from negative to positive. So on the chart, F would switch from concave down to concave up. So F is an inflection point right there. Right here, F double prime is negative and stays negative. So therefore, F would be concave down and stay concave down. Okay, so one inflection point at x equals 2. Sketch a graph of F prime. So let's do that in red. So again, these y values are the slopes I'm going to draw. So these y values are negative but getting towards 0. So this graph is going to be going down but leveling off right there. Then I got negative y values getting more negative till there. So it's going to be going down, 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 steeper and steeper till about there. Then they're negative and getting towards 0. So it's going down but leveling off, like so. Then it's positive and getting more positive, so it's going back up. So something that looks like that. And here we see our local min, right? We go from negative to positive. Now a minute ago we were talking about that as an inflection point. That's an inflection point of F. But it's a local minimum on F prime. When F double prime goes from negative to positive, F prime goes from decreasing to increasing. Local minimum. Okay, here we said we had a flat spot. F double prime is negative, stays negative. F prime is going to decrease, keep decreasing. Okay? All right. So that would be what you want for 43. All right. So now let's talk about 22 and 21. So we've done a lot just by going through those problems. We've done tons of review of the chart right there. I mean, we've been hitting it all. Concave up, concave down, inflection points, all that stuff. F prime, F double prime, F prime, whatever. All those different connections. Now, we get to 22 and 21. These involve the speed limit law. Let's do 22 first. 22, let's see. I think I have a picture. No, I don't even. I don't have a picture of that one, so let me put it up here. All right, so this, forgive me here for how bad this is going to look. Let's give this a try. I get straight on. I think I can run. All right. So this is, what is this on 22? Or, well, 22 actually doesn't deal with this picture, but okay. So let's do 22 first. So 22, they tell me that, well, first of all, that first sentence is stuff that's not a big deal. Suppose the function f prime, f double prime are continuous from negative infinity to infinity. Okay, that just means it's a nice function, nothing weird going on. F prime of 2 equals -1. Now, anytime there's a speed limit law kind of problem, maybe we give you a hint that it's a speed limit law, or maybe you just realize it kind of looks like one. I think after we review today some of the homework I gave you, you're going to recognize the speed limit law problem. When you see a speed limit law problem, first thing you ought to do is start graphing it. So I'm going to make an F prime graph, and I'm going to come over here to 2, and I'm going to graph 2, -1. Okay? So they give me that point. Then it says that F double prime is between 0.1 and 0.5. Now here's how to summarize a speed limit law problem, okay? Let's encapsulate it here. A speed limit law problem is this. They give you a starting point, like Bismarck, or a point on the graph. And then they say how fast you're going to go, or they give you the slope. That's the same thing. They tell you something about the slope. Well, that's what they did right there. F double prime is a slope. And then they say something about some ending point. So they give you a starting point. They tell you how much you're going to go over. And they tell you the slope, which tells you how much you'll go up. Right? I mean, that's what slope is rise over run. So that's basically a speed limit problem. Start here. Here's how much you can go over and up. Where are you going to end? That's really it. That's speed limit law. Okay, so here they give me a starting point. They tell me that I can maybe go up 0.1 or maybe 0.5 if I go over 1, rise over 1. This is my slope. So then they ask me what's an upper and lower bound of f prime of 3. Okay, well, I'm here at 2. They want me to go over to 3. Well, that's a run of 1. So if the slope is 0.1, that means I could go up 0.1 right there. Or I might go up as much as 0.5, which would be right to there. I can go somewhere in between those two. Well, what would this point be if I went up 0.1? Negative 0.9. If I went up 0.5, negative 0.5. F prime of 3 has to be somewhere between those two. So that's what they wanted, an upper and lower bound, right? An upper and lower bound on f prime of 3. In other words, they're saying if we let you go up this much and you start here, where will you end up? You're going to end up somewhere between negative 0.9 and negative 0.5. That's a speed limit law problem. It's very similar to ones we had done earlier. Okay, so a picture, maybe a few words of explanation would be good for a problem like that. All right, now let's look at 21. 21's a little bit different in the sense that it doesn't really even look like a speed limit law. Now let me try to graph this. So 21 is referring to this graph right here, which is G double prime. This graph starts up here, comes down to 1, goes up a little bit, crosses at 3, and comes back down. So this is 3, kind of about 2 is here, 1 is here, that's not bad. All right, and so it's up here at 3, and this, that's 2, and that's 1. Okay, all right. So, all right, so they say then, on number 21, suppose that G prime of 1 is equal to negative 3. G prime of 1 is equal to negative 4. All right, now let's back up just a second. The other class had a question about 19, so maybe some of you have a question about 19. Ranking these 4 numbers. Now the key is they ask about G prime of these 4 numbers. Here's all you need to know. You want to know about G prime, they give you G double prime. G double prime is what? The slopes. These Y values here are always positive, except right there where it's 0, but they're always positive. So therefore the G prime graph is what? Always going up, always increasing. So the G prime graph is always going up. So the G prime is always going up. They're already in order, right, on 19. G prime of 0, G prime of 1, they're going to keep going up. So those Y values are going to keep getting bigger. So that's 19. Okay, 21 says, is G decreasing at x equals 3? That is the question. Okay, now this is a tough one. This is the first one we run into where we have to really put a bunch of different pieces together. On our first quiz, I said that there will sometimes be questions where you know all the different pieces you need to be able to answer the question. You just may have to put them together in a way you've never had to put them together before. And that's what happens in this problem. Okay? So the question is G decreasing? Now the first thing I would do is I would draw myself a G prime graph. As soon as they give me a point on a G prime graph, I'm going to plot it. Okay, so I'm going to go in here and I'm going to plot this point. And I may not end up meeting it, but it's a good chance I do. So I'm going to do that first. So G prime of 1 is 4, negative 4. I'm going to plot that thing. Okay, now, let's look at the question here. Is G decreasing at 3? So I'm going to think, when I see decreasing, I'm going to think of the chart. So when G is decreasing, what's that mean? Okay, so this question really is, I'm going to cross that out, and I'm going to answer this question. is G prime of 3 negative? That's really the question. Because if I can answer that question, I can answer their question. Because if G prime is negative, then I'll know G is decreasing. Because I don't know anything about G. All I have is G prime and G double prime information. How can I find out about G? So I go to the chart and I want to know if G prime of 3 is negative. So really, if I look at my graph, what's that saying? Well, G prime of 1 is negative 4. So the question is, where is my point over here? Well, that's where speed limit law comes in. If I go over 2, how much am I going to go up? That's the real question. Well, how do I tell how much I'm going to go up? The slope, right? I need the slope. Well, do I have the slope? Sure I do. It's right there. So what I'm going to do is come over to this graph and I'm going to look at these y values. Now, between 1 and 3, what are these y values? They are below 1. So therefore, if I go over 2, I won't even go up 2, right? Because the slopes I can get from the G double prime graph tell me that the slopes never hit 1. That's kind of like what was happening back in this problem when I told you what the slopes were. The slopes were between 0.1 and 0.5. The only difference here is I gave it to you in graph form. The slopes were between about 0 and about 0.6. That's the only difference. Here I gave it to you this way. Here we gave it to you in graph form. Same amount of information. All right, so these y values never get above 1. So therefore, if I go over 2, I'm not even going to go up 2, which tells me that my G prime of 3 is going to be what? It's definitely going to be down below the x-axis. So G prime is going to be negative at 3. So therefore, back to their question, G will be decreasing. That's a lot to put together, right? But we know every bit of that. We can do every bit of that. We should know what those things mean and so forth. We can answer a question like that. It's there, okay? But that's a tough one. Yes?
I thought when G double prime switches from positive to negative, G switches from concave up to concave down.
Yes.
So isn't that difference?
Right.
Isn't that increasing?
No. Because, what did you just say, concave up to concave down? Right there is a G graph that's decreasing, concave up, switches to concave up. Okay? Yes, I think what you're referencing is right here, right? That's what's going to happen. So there is an inflection point, right? So if we graph the G graph, that is what would have to be happening. But yeah, it could be decreasing. Yes. All right? So is G decreasing? In this case, it is. All right. Anything else in that homework? Anything else in that homework? Okay. You know, that's an interesting point you just made there. Let's talk about, let's investigate that just a little more. What that brings up is that concavity really has nothing to do with increasing, decreasing, does it? Right? Because here's a concave up to a, here's a concave up to a concave down. The graph's decreasing. Here's a concave up to a concave down. The graph's increasing, right? So concavity and increasing, decreasing don't have much to do with each other. Now do the other way. Concave down to a concave up could be an increasing situation, or concave down to concave up could be a decreasing situation, right? So concavity may not have anything to do with increasing, decreasing. They're two separate issues. All right. If there aren't any other questions, and we will have some time to ask individually, so let's go to your notes and maybe you want to jot a few things down. Let's talk about the quiz. Let's talk about some of the problems, and then I'm going to give you some problems. We don't always, it would be great if I had this great set of exercises to review all the time. We don't always have that. For this quiz, we have some decent ones that you can go back and do, and I'll try to give those to you and give you some work time here today to do them. Okay, so let's talk about section 1.4. So section 1.4 is where we were introduced to the concept of derivative in f prime. We said that that was slope at a point, that was instantaneous rate of change. And we started out talking about some issues like with speed, velocity, and so forth. And one of the first things we did was at Bismarck, the car going east of Bismarck. And we talked about translating some sentences. Okay? For example, if you remember that car going east of Bismarck situation, P prime of 2 equals negative 70, put that into words. At 2, that's right. At 2, we said at 2 o'clock because it started at noon, but at 2 hours, the car is going west at a velocity of 70 miles per hour. The negative means west. We don't know if the car is east of Bismarck or west of Bismarck from that information. We just know it's going in a westward direction. Now, if I told you that P of 2 was 100, now where's the car? At 2 hours, it's 100 east would have been positive. So there, in that case, if you had both of those pieces of information, the car is 100 miles east of Bismarck and it was coming back towards the west at 70 miles per hour. So be able to just translate that. Now, here are a couple of problems I picked out from the book. There are some on your review problems today that also are some translating ones. But number 41 or 40, I think, 41 was the one we did with the minutes of daylight. You know, at 100 days past January 1, the hours of daylight are increasing by 3 minutes per day or something like that. So 40 and 41, you want to revisit those. Those were ones where you had to do that. I also have some new ones for you to do as well. All right, the speed limit law. Now back up page 45. And we just did a couple of speed limit law ones. Back on page 45, 24 through 30, there's a section there with several speed limit law problems, if you want to revisit those. Now, I also have, in the review problems today, I have some speed limit law problems too, that you can look at. Okay, now this is the part of the quiz where we are going to use the calculator. Okay, and so on the calculator, this was problem 54. I believe it was on page 46. And it was about the metronome. If we threw the baseball up, it would have hit the ceiling, and how high does it go? And so we needed this to be able to maybe plug this into our calculator to solve or to graph. And so when does the ball hit the ground? So we take that H equation, set it equal to 0, do a solve. Okay, so you might want to go back and look at that problem. I don't think there's any of those in our review problem. So this would be a pretty good one to go back and make sure you can use your calculator. Pretty simple. I think the calculator part of this quiz will take 5 minutes, 10 minutes. The rest of it, the other 3 pages are no calculator. Right? 3 pages because when you do these graphs, they take up some room. But most of the quiz is no calculator. Okay, so that's what we did in section 1.4. So we haven't done a few of those things for a while, although we just did the speed limit. Okay, section 1.5 was about zooming. Now, I'm not going to be interested in you getting on your calculator and zoom in, zoom in, zoom in, zoom in until the line's straight. That's not what I care about you doing. Zooming really means pick 2 really close points and do a slope. So that might be, this part might be, you might be asked a question about this on the calculator part as well. So if I give you a function, just be able to plug in, like what we did is we traced, like we would graph maybe a function, we would trace to 3.001, we would trace to 3, we would write down those points, we would do our slope calculation, and that would be an estimate of a derivative of a slope. So you might have a problem where you need to do that. So make sure you can do that on your calculator. Okay, pretty easy calculation to do. Okay, The other type of zooming, I guess you could call it zooming. That's why I put the zooming in quotes, because we're not going to literally zoom in necessarily. But where we just sketch a tangent line. So when I give you a problem with some graphs and ask you these various things, I may ask you to estimate. I may give you an F graph and say estimate F prime of null. Or I might give you an F prime graph and say estimate F double prime of null. Well, that would be the slope. So you just sketch in your tangent line, do your little slope triangle, estimate rise over run. That's also kind of an element of zooming. So be prepared to show you can do those kind of things. Okay? And then 1.6 and 1.7, there's not much to say. I mean, that's most of the quiz, and that's most of what we've been working on. The chart. Now, somebody in the other class asked if they could use the chart in the quiz. Well, in the sense that if you can recreate the chart, yes, you may, but you will not be allowed to have a chart sitting on your desk when I pass out the quiz, right? And before the quiz, I'll go around and I'll look at your desk and erase, those charts that you got drawn on your desk. But no, so that's the idea. So, like I said, many of you may, when you get the quiz, the first thing you do is scribble out the chart up at the top of your paper. That's fine. So that might be something to review. Practice writing out the chart. Practice writing out the chart. Might not be a bad thing to do. Okay? And so all these questions we've been asking, when I talk about chart stuff, I'm talking about any questions that ask, where is it increasing, where is it decreasing, where are the stationary points, where's the concave up, where's the concave down, where are the inflection points, where's the local max, where's the local min. Those are all chart kind of questions. And there'll be a bunch of them. All right, so for the last 45 minutes, we're going to go ahead and go to work. So why don't you grab your Chapter 1 assignment sheet here. And got a whole bunch of problems here. Now, I am not going to be going around and checking this before the quiz. This is for you to review. It's a lot of problems. We are going to skip a couple of them here. And then there's a few that I'm going to put down as they're okay to do, but you might want to spend time in other ones probably. So 2, 3, 5, 6, 11. Let's see. I can't remember about 50. These the ones I'm underlining are ones that are just kind of they're okay to do, but yeah, 53 I would skip. Okay, so 2, 3, 5, 6, 11, 99 out here. To me, those are ones that are okay to do, but I would maybe do those last. 9 I would skip. It's a good problem, but it doesn't really have anything to do with the quiz tomorrow. 53 I would skip. So those are probably the 2 I would skip. The rest of them, starting with 14 through 22, 14, I don't know why I put 14 and then 15 through 22. Yeah, 14, 15 are good ones. That's where, you got to figure out which graph is which, that kind of stuff. Those are good ones for chart kind of things. 25 would be a calculator one. One where you would just draw the quiz or draw the graph on your calculator and then answer the questions about it. 28 through 33 are speed limit law problems, so those are good ones. 35, this whole group here, 35, 38, 39 are good ones. 41 through 51, so I would do, looking at those would be good review. 61, 76, and 80 are good ones. That's at translating it into a sentence. Okay, that's what that section's about. Those three problems are about, so those are good. I would add one. Since I took away 2, maybe I should add one. 82 is not a bad one. It's some more chart kind of stuff. 84 is a good one. We can do that. 86 through 91, those are all good as well. Okay, so most of those are the ones I circled would really be the ones I would kind of focus on. Those ones I underlined are okay, but they may not be quite as important for the quiz. The ones I crossed out for sure don't really have much to do with the quiz. All right, and let me see. Now that's not probably a full review of everything. There isn't anything on those, that number 54 I mentioned that was on page 46, that one about the height of the ball when you throw it, so you might want to do that one. And also, there isn't anything in here on the zooming. So if you want to do some on the zooming situation, number 10 and number 11 on page 52 might be good ones to look at too. If you want some for zooming. So if we think about what we just went over as far as what to know for the quiz, I think it's all in here. There's a lot of chart stuff. There's some speed limit law. There's some translating. This would be one with the height of the ball, the zooming stuff. These two down here at the bottom would be the ones where you kind of use your calculator. Okay? All right, so you got the rest of the time to review and work together and ask questions. Come up and ask for help from me if you want. A few people in the other class took some of these cards and practiced kind of matching those up. Oh, there also are some in your book where you had to do some matching too. If you want to do some matching with those are good practice things to do too. All right. Good work. Yeah.